All right, so chapter 7, brand new chapter, brand new marking period, first day of the marking period. So let's do what we're supposed to do. Let's make sure we take good notes on this. And you should be good. All right. What I'm going to do is I'm going to draw a rectangle. All right, that's a good start since that's the first thing they talk about here. And what I'm going to do is I'm going to divide it up. Now, I may not do this perfectly. Okay, I wasn't quite perfect on the last class, but I'll try my best. I'm going to try to break this up so they're all squares inside of here. All right, so do your best. So draw a rectangle in your notes. There we go. Actually, that looks pretty good right there. But I'm going to do more. Let's do this. Again, I want these to be what inside of here? What did I say? I want these to look like what? A sail? Is that what you said? Maybe drop that down. That's pretty close. It's not perfect. It's good enough. All right. What do you think these things are inside that big rectangle? They're a bunch of what? A bunch of squares. They're a bunch of squares. Okay. So here's what we're going to do. Nate, you said the area of a rectangle is what? Length times width. So a lot of times they'll make this the length and they'll make this one the width. And it actually does not matter. It doesn't matter which one is which. All right. This could be the length or this could be the length, right? Because those two are the same. This could be the width or this could be the width. Or you could change it around. You don't have to call this one, this short one, the width. You could have called it the length. You could have called this long one down here. You could have called it the width. It doesn't make any difference. Okay? But we're not going to use the words length and width. There's nothing wrong with that. He's perfectly right when he tells me the area of a rectangle is the length times the width. But what we're going to do is we're going to use a couple different words, and we're going to continue using those same words for the other stuff that we're going to find areas of. All right. So instead of length or width, it doesn't matter which one's which, we're going to call this, let me get rid of this, we're going to call this the base. And what am I talking about? I'm talking about from here to here. Everybody see that? So that distance, okay, from this point all the way to this point, the length of that rectangle, I'm going to call the base. And this one, I'm going to call the height. Okay? And where is the height? It's from here to here. Everybody understand that? All right, so this length down here on the bottom, we call it the base. We call this the height. Now, what if I asked you to find out how many squares are inside that rectangle? What would you do? Okay, count up the height. How many are there? 4. Count up the base. How many are there? There's 8. Okay, so how many how many squares are there inside our rectangle? 12? You could just count them all, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You could do that. Well, that'd take forever. What's a quicker, easier way? If I know there's 4 up and down and 8 across, 4 times 8. That's right. Okay. And so how many squares? Keep saying rectangles. How many squares are inside that rectangle? There's 32 squares. You with me on that? And everybody knows how to do that, right? If you have a rectangle that's broken down and they're all even, just count how many up and down, how many across, multiply them together, and you got how many squares are inside that, right? That's the same thing as the area. When you find the area of something, what you're finding is how many squares can you fit inside that particular figure, all right? We're going to do more than just a rectangle, okay? Even today, we're going to do more than just a rectangle. But for right now, understand that if I find the area of any figure, I'm trying to find how many squares can you fit inside of there. Josh, you had your hand up? Doesn't make any difference. Nope. Because 4 times 8 is the same as 8 times 4, isn't it? So does it matter that you called this the height? Was it that important that you called it the height? No, I could have called this one the base, couldn't I? I could have called this one what? The height. Yeah, it doesn't make any difference. Everybody got that? Okay. So here's the formula for the area, I'm going to put an R right there. What do you think that R represents? The area of a rectangle, okay? So I just put a little R underneath of there, okay? And all it does is say the A stands for area, the R stands for rectangle. So the area of the rectangle is the base. What? What did I do with that base and that height? I multiplied them together, right? So the area of a rectangle is the base times the height. And that's very basic. That's probably the easiest one that you'll ever do, okay? Area of a rectangle, all right? It's just base times height. Just multiply them together. Make sense? All right, let's talk a little bit more about this. Right now, I'm just saying that there's 4 squares, all right? But a lot of times, if you measure something with certain units. I'm not going to tell you. You're taking a test.
No. It's so I could figure out with my reading.
No, you turn in your test and I can answer a question like that. Excuse me. All right. So here's what I'm saying. If I was to measure from here to here, I had a tape measure. I could measure this in a bunch of different ways, okay? I could measure it in, or if I had a ruler, I could measure it in centimeters. I could measure it in inches. I could measure it in feet, depending on how big a thing is, right? Would you agree? So it's a certain units. Let's just use inches right now, okay? So let's say that's 4 inches. What is this 8 then? If I measure this is 4 inches, then this would be what? 8 inches. Now watch very carefully on how to find the area. So area is base times height. What's the base? 8. But it's not just an 8, it's an 8 what? Inches. Times the height. What's the height? It's 4 what? Inches. And what do we get? 8 times 4 is 32, just like we said. But check this out. I still got to multiply the inches. What's inches times inches? Inches squared. Very good. Heard that? Okay, it's inches squared. We're not squaring the 32, we're just squaring the inches. I don't know if you've ever done this, maybe with your parents or somebody. You've gone to the store, maybe at Home Depot or Lowe's or something like that, and you're buying carpet, or I don't know if they sell carpet there, but they sell flooring. Let's say you're going to buy some flooring, or you might buy some plywood or something like that, okay, at a store like that. They'll have a certain dollar amount, I don't know, let's say $3 per, okay, a lot of times you'll see a slash or see a PER, per square feet. Has anybody heard that before? Square feet. And a lot of times, like if you go to a store, they probably write it SQ, all right, for square feet. But how are we going to write it in our class? We're going to write feet what? Squared. Square feet and feet squared are the same exact thing, all right? So this is a lot of times, if you go somewhere and you're going to buy something that's got a certain area to it, you might see it in square feet. It means the same thing as feet squared. It's area. It's how many little squares can you fit inside of that object. You got it? That's what you're doing when you're finding the area. I think it's important to understand what you are actually trying to find. All right, I think I can move on to the next thing. Now, this is not in our list of things we're finding the area of, but it's basically the same thing as a rectangle, because that is a rectangle. It just happens to be a rectangle with what? All 4 sides equal. That's right. Okay. Oh, almost forgot. One more thing. I knew there was something I was missing. If I'm going to talk base and height, the base and the height always have to be perpendicular to each other. What does that mean? If this height and this base are perpendicular, what kind of angle do they make? A right angle. Very good. 90-degree angle. Everybody hear that? That's super important, especially for what we're going to do at the end of this lesson. All right, the base and the height have to be perpendicular. All right? Let's go back to this. Well, this is a square, so guess what? That's a right angle, isn't it? If it's a square. You could call this the base, and you could call this the height. But what's true about the base and the height? They're the same, aren't they? So, and I'm fine. If you say the area of a square is the base times the height, that's perfectly fine. I got no problem with that at all. All right? But here's what they do in the book. Instead of calling it base and height, they give it the letter S. Why do you think they used S? S for square? They're all the same. S for side. Very good. Okay. So they use S for side. So how would I find the area of this? It's side times side. Good. I'll put a little X. I don't usually put X's, but here I will. Now let's put a dot instead of an X. Okay. Side times side. But what's a better way? Oh, I probably shouldn't put side. I put a word there I probably shouldn't put. Anyway, that's okay. It's nothing you haven't seen before. All right, so what do we got here? Side times side is the same thing as what? Side squared. Very good, because anything times itself, I just hate that staring me at the face, so I'll get rid of that. All right, so side squared is the formula for the area of a what? Square. All right, so this right there is the area of a square. The only problem I have with this is it's like one more thing you got to remember. All right, you can just remember the area of a square is the same as the area of a rectangle. What's the area of a rectangle? Base times what? Height. So you could call this base and height. It's fine. All right, but this is what they call it. They call it side squared. All right, so let's make up our own example. Say the length of that was 5. So what is the area of this square? And I only give you one side, but I tell you it's a square. So what's the area of it? What do I do? It is. It's 5 what? 5 squared, which is 25. Okay? Now, like right here, I didn't tell you if it was in inches or centimeters or millimeters or anything, did I? If they don't do that, here's what they do in the book. So if you flip to the back of the book and find an answer and they don't have it any units right here, this is what they do. They put units, what do you think? Squared. Or sometimes they'll put just the letter U squared. Again, you're not squaring the 25. You already squared the 5 to get 25, okay? So it's units squared or just U squared, 25U squared. Okay, enough of that. Let's go to the parallelogram. The nice thing about the parallelogram is that it's the same exact formula as the area of a rectangle. What was the area of a rectangle? Base times height. What was the area of a square? Base times height. And if I said the parallelogram is the same as those two, what's the area of a parallelogram? Base times height. Very good. So that's kind of nice. Now the next one to do the triangle is not base times height, but it's close to it. It's close to it. So let's draw a parallelogram. I mean, that technically is a parallelogram, but this is what you normally see as a parallelogram. Would you agree? Yeah. All right, this side and this side are equal. These two sides are equal. These are parallel. These are parallel. All that stuff we know about parallelograms. If I call this the base, now don't write this next part down. Everybody hear me? Is this, I'm going to put a question mark. And if I'm going to put a question mark, you probably know the answer to this. Is this the height? If this is the base, is that the height? Autumn, you with me? Snap out of it. Okay, if this is the base, is that the height? What did I say earlier that has to be true about the base and the height? Are they perpendicular? No, there's no way they're perpendicular. They didn't tell you it's perpendicular. Sure doesn't look like they're perpendicular. So, if this is the base, can that be the height? No, that is not the height. You're like, well, where is the height? I don't see anything that's perpendicular. Okay, well, what we're going to do, and this is what they usually do. They usually don't use a different color. They usually use a dotted line. All right, but watch this. Now, tell me something about that. Okay, you could think of it as the altitude. That's good. You're going back. But as far as this, as far as base and height, what is that red line right there? That's the height. This is the height. Okay? Not the slanted one. Everybody see it? Why not the slanted one? Why is that not the height? It's not perpendicular to the base. You got it. Okay, very good. All right, so the base and the height have to be perpendicular to each other. You got it? All right. So that's the height, or if this is the base, then that is the height. You could have all kinds of heights on here. You could go like right in the middle if you wanted to, or anywhere inside of there. What's that? That's also the height, isn't it? All right, sometimes they might draw it like that. What's this one right here? That's the height. Very good. All right, so you got three different, well, they're not different. They're all the same length, aren't they? So if this was 5, then what would this be? 5. Then this would be 5. Here's another way they might write it that looks kind of weird. Sometimes they'll do this. They'll take the base and they'll put a little dotted line here to just extend it out a little bit. All right, and then they drop down a perpendicular to there. Come on. All right, and that would also be the height. So if that's the height, so is that, and so is that. Even though it's outside of it, that's still the same length as all the other ones, isn't it? As long as you extend that out, right, the same direction, this is still the height. So those are all the height. So what is the area of a parallelogram? Yeah, it's just the base times the height. Wait till somebody left. Who left? Ariel. Wait till Ariel comes back. So the area of a parallelogram is equal to, look at that, the base times the height again. That's all you had to do. All right? Everybody see that? So that's kind of nice. All three things so far have the same exact formula. All right? That makes it kind of easy. But you got to understand that this is the base, and this is the height. Any of those could be the height. Not this one. Okay? It's very important that you understand that. A lot of students will make mistakes and consider that to be the height. But it's not. All right. Let's do an example with a parallelogram. And I'm going to draw the parallelogram a little bit different. Try to draw it like they did in the book. Let's see. There we go. Let's not make it so skinny. All right, there's parallelogram. That looks nice enough. And they give you some stuff. This is an example. This is an example 2. And they tell you that it is a parallelogram. It's parallelogram ABCD. And this is what they tell you. They tell you, if I could draw this right, boom, boom. Parallelogram ABCD. All right, so this is what they tell you, that it is a parallelogram, and they give you some information. So let me give you some of that information. All right, they tell you that DC is 13. Everything is in inches. They tell you AD is 25 inches. And they do this. I'm going to do this in a different color. They go from here to about right there. And they tell you that that's perpendicular. And they tell you the length of that. They tell you it's 10 inches. And what do you think they're going to ask you to find? No? What have we been doing? No? Not just the height. What? Area. Very good. That's what we've been talking about this whole time, right? So it says find the area of this parallelogram. Find the area. Well, first of all, do we know a formula for the area of a parallelogram? We should. It's the only formula we've talked about today. It's the base times the height. Very good. So A. But what has to be true about the base and the height? They have to be what? They got to be perpendicular. 35? Okay. Why not the 13? It's not perpendicular. Right. It's not perpendicular to this one. All right. So, but wait a minute. That 10 right there is not perpendicular to this 25, but it is perpendicular to this BC, isn't it? And what is the length of this BC? 25. It's also 25 because it's a parallelogram and the opposite sides are equal. So look, this D, we'll call it E. This DE is perpendicular to BC. So DE, the 10, and the BC, the 25, they are perpendicular to each other. So one is the base and the other is what? The height. And I don't care which one's which. It doesn't make any difference. You're just multiplying them together anyway, aren't you? So let's plug it in. Area equals base times height. What do you want to call the base of this? Let's call this one the base. All right? So BC. So how much is that? 25 what? Inches. So make sure you include the inches. What's the height of it? Which one's perpendicular to the 25? The 10. So 10 inches. Well, what do we do with that 13? Leave it alone, right? Don't worry about it. It's got nothing to do with finding the area of this. Zion, you getting all this? Sorry to wake you up from your nap. All right, let's do the math. Now we do the math. It's very easy. You can do this in your head. 25 times 10, 250 what? Inches squared. Don't square the 250. Everybody hear that? Just square the inches. So that's the area. What did we just find? We found out how many what? How many squares, right? How many 1-inch squares can you fit inside of this thing, okay? And that is the area. How many squares can you fit in is finding the area of something, all right? Make sense? So if I could draw a bunch of squares, you know, and you counted them all up, there'd be 250 of them in there. I'm not going to do that. Okay, let's do another thing. What's the only one we haven't talked about today that was on our list? A triangle. So, of course, I'm going to draw a what? A rectangle. You're like, what? Thought you said we're doing triangles. Well, we are. But I'm going to do a triangle. I'm going to do a triangle. Just watch. Everybody watch this. If I drew a diagonal from this corner to this corner, what did I just make? I made 2 triangles, didn't I? I got one triangle right here, and I got a second triangle right here. Tell me something that's true about both of those triangles. They're equal. They're congruent to each other, okay? They're exactly the same. Everybody with me? Autumn, snap out of it. Come on. Write this down. If you're writing down, it's easier to stay awake. It's not perfect because I've done that plenty of times in the middle of writing something or typing on my computer. I wake up later with my head right on the computer. All right, so I understand it. But it does make it easier to stay awake. So write it down. So I've got 2 triangles. Let's just take one of these triangles, this one right here. I'm going to shade it in. This is my shading. This is how I shade it in. Whoops, went off a little bit, but you get the idea. Okay, you see the triangle, don't you? All right, that's going to bug me right there, so I'm going to get rid of that. There's my shading. Okay, so what I want to do is I want to come up with a formula for the area of a triangle. Is it still just base times height? Do I go base times height? No. I mean, this is the base. This is the height. Remember, this was a rectangle, so that's perpendicular. So what is the area of a triangle? It's the base times the height divided by 2. Very good, because this is only half of the rectangle. This is the whole rectangle, base times height. So how do I find the triangle? I just take the base times the height and do what to it? Divide it by 2. Does that make sense? Is it what? Yeah, AT. Why AT? Appalachian Trail? No. What is it? Area of triangle. That's right. Area of a triangle. Or you could write it another way. Remember, it's half of the rectangle, correct? Half is dividing by 2. Or you could write an actual fraction, 1/2. Times what? Base times height. That's the same exact thing. Just a couple different ways to write it. Make sense? Okay. Giving you a second to let it sink in a little bit. All right. So that's our formula. Write that down. Okay. It's this or this. It's the same thing. It really means the same thing. Dividing by 2, multiplying by 1/2 is exactly the same thing. Okay, let's do an example with a triangle this time. So let's draw this. Let's draw this. We'll go to there. All right? So this is not a right triangle like we did before. Now, if you have not paid attention at all, now's the time where you should start paying attention, okay? Because this one is going to be a little trickier. They make the bottom of this 12, and it's in feet. Well, it's not going to be a parallelogram, but Yeah, I am going to put a height in there because watch this. Is this side right here the height of that triangle? If this is the base, okay, I'm considering this to be the base. Is that the height? Is that the height? No. Where does the height go from and to? It goes from this point up top here. Where to the bottom? Here to the bottom? Not straight. What word do we use? Thank you. Perpendicular to the base. That's the geometry word we're using. And they do give you that. They give you that on the picture, okay? But they don't tell you what it is. They just put that as H. Okay? So we're missing something. Yeah, they give you the area. Very good. Okay, they give you what the area is, and it's 54. Oops, let's try that again. 54 square feet. So they actually give you the area, and you got to find the height. Okay? It's really not that hard, I promise you. So what I'm going to do, we have a triangle, don't we? Do we know how to find the area of a triangle? Do we know the formula for it? Yeah, I'm going to use this one. Base times height, what? Divided by 2. Okay, Matt, are you getting all this? This is where you got to pay attention. So what I'm going to do is I'm going to plug in all the stuff that I know. So what do I know? I know the area. What's the area? 54. Okay. On this, I'm not going to put the units. I'll put it at the very end. Okay. So 54 equals the base. Do I know the base of this thing? It's 12, right? So I'm going to put a 12 times the height. Do I know the height? Nope. So what am I going to do? Put it right there. I'm going to, well, you're getting ahead of me. All right. So what do I do for the H? I just put down an H. Okay. I got to finish up this formula. What do I have to do to that formula? Put it over what? Put it over 2, because that's the area of a triangle. Base times height divided by 2. Now what I got to do is I got to solve for H. I got to get H by itself. This math is actually kind of easy. Because what can I do over here on this right side? Yeah. So I go 12 divided by 2. What's 12 divided by 2? It's 6. 6 what? 6 times H. That's right. We still got the H over here, right? That's all I did. I went 12 divided by 2 is 6. You still got an H, so I put the H here. All right, see the algebra? It's not even really algebra just yet. All we did was just take 12 divided by 2, and we got a 6 out of it. That's it. Divide both sides by 6. Okay, 6 cancels out. What's H? 54 divided by 6. Can you do that in your head? Do you know your multiplication tables? Oh, you're using fingers? That's right. 7. 7 times 6 is 54. What times 6? 9 times 6. So H is 9. You got to know your multiplication tables. All right? And schools have done a disservice to kids by not making them memorize their multiplication tables. Wouldn't it be a lot easier in life if you just knew what your multiplication tables are? I know. Well, I'm saying you got to stay up on it. So H is 9. Before I circle it, though, it's not just 9. It's not just a plain old number 9. It's 9 feet. Everything's in feet. So make sure you put the units. 9 feet. Yes? No. This could have been centimeters. They just decided to make it feet. All right? The fact that it's a triangle has nothing to do with what units you use. Okay? So that right there was the hardest one you had to do. But really, it wasn't that difficult. What'd you do? You just took your area of a triangle formula, you wrote it down, and then you just plugged in everything you know. Okay? A is what? 54. So I put a 54 in the A. The B is what? It's 12, because that's the base. All right? So I put a 12 in for the B. Don't know what H is, so I just keep it H. Then I had to divide it by 2, because that's what my formula says to do. 12 divided by 2 is 6. 6H. Divide by 6 to get rid of the 6. And then 54 divided by 6 is 9. It's as easy as that. But you got to practice it. Okay, just sitting there and either watching me or going to sleep while I'm talking is probably not going to help you that much. It'll help listening to me, but you got to do these on your own, okay? And that's why I give you homework. I don't give it to you as a punishment. I give it to you so that you can learn how to do this stuff. All right, so here's your lesson. It's 7-1. There's no A or B on this, and it's numbers 1 to 19. It's pages 301, 302. We're in the 300s now. Isn't that exciting? Maybe, maybe not. All right. I don't know. It is for me. So section 7-1, you're doing 1 to 19, and that is your homework, and it is due tomorrow. Again, listen to what I said earlier today, okay? This is the first homework of the new marking period, first homework of the last marking period, all right? So start off with a 5 out of 5, all right? Start off with 100% the first day, and that's the best you can do. So it's at least a good start. Whether you continue it or not, it's up to you, but at least it's a good start. Get it done, and try to do them. Don't just look at it and just write down a bunch of mess. Don't turn to the back and write down all the odd answers and then just fill in the evens with some kind of mess. Actually look at it and work on them and try to figure out how to do the problems. This is where you learn, okay? Doing the homework problems on your own, that's where you learn. Sitting and watching me, watching the video, sleeping through my class, whatever, that's not learning, all right? Learning is doing. You have to do it. That's why I give you the homework. Again, it's not just busy work. That's not what it's for. It's so that you can learn it, all right? Plus, where do I get the quiz questions? From the homework. Where do I get the test questions? From the quizzes. Where do I get the final exam questions? From the tests, okay? So it all goes back to doing what? The homework, all right? It all depends on your homework. So give it the best effort that you possibly can. All right. I've been so inspiring today. I'm just wearing myself out. Thank you. At least somebody laughed. All right. Get it done.